Okay, well, I hope you have all scanned my QR code. And I think I have mentioned from last discussions that probably this will be today and next Monday will be our last lectures. And the materials itself will be finished today. So I will finish chapter 15 by today. And next Monday will be just a review. And I will not count the attendance for the Monday class. So you can choose if you want to skip my class or if you want just come to the class and review the materials. That's okay. But if you want to skip and maybe you have other schedule for I think other final exams, right? For preparation, that's also okay. I don't mind. So it can be your so today can be also your final lectures too. Okay, I think we can move to our notes. Yeah. Okay, last time we discussed the applications. How do we use the change of variables, or in our case is how do we apply the Jacobian transformation, in which this is how it looks like when we apply to a polar coordinate. So when we convert to polar, we can convey a Jacobian transformations, and we convert the x, y into the r, theta. Okay. In our case, usually in change of variables, usually we change x, y into u and v. Okay. So you can change the variables into other variables as well. But usually we are using u and v. Okay. But this case in the polar, we can just look at when we have the r theta. Or you can just write in terms of u, v, that's still okay. But this is to show you that it has connection with the polar, and the results and the conclusion is the same conversion, the same double integral conversions. Okay. All right. I think yeah, probably giving you example from the textbook and other exercise as well for this Jacobian. I think it can be helpful. And let me continue the wait in this part. Okay, okay, fine. The double integral. Okay, for this double integral of region R. Okay. The function is e with power of x plus y over x minus y dA. The region R itself is have it has the four vertices 1, 0, 2, 0, 0 point negative 2, 0 point negative 1. So I think for some cases in the change of variables, whenever you can draw the curve or draw the shape of the image, I think it's really helpful to see how it changed, how it maps to another region. So you can see the change in terms of the shape. Okay. But before we look on the shape, okay, I want you to be observant for these cases. Okay. If you look on the function itself, the e, okay, we have x plus y and x minus y, right? So if we just take a look at this composition, and if we think clearly that we can make our new variables as u and v, and if we let the u as let u x plus y and v x minus y, and then by doing so we can make some set of a new pair of coordinates, right? We can have u and v, a new u and v from here. So xy is this one, right? The vertices. This is for xy. For uv, you can just make this plus become 1, and then for v is x minus y, so it's just 1, another 1, right? Do the same thing and you will get a new set of vertices, right, for uv. And I think from what we have doing, I think it's applicable, it's doable, but rather than doing that directly, I will just to show you the image, okay, the sketch, the curve, and how it's changed in the new one. But if you want just directly to see that x plus y and x minus y becomes u and v, that's okay. And if you think that why we need to change the variables, well, if you want to directly integrate this part, okay, if you want to directly integrate this, it will be very difficult. If you want to maybe take dy first and dx, or maybe dx first and dy, is it easily to be integrated? I don't think so, right? It seems a little bit difficult, or rather complicated, right? So that's why if we change this into u and v, this will be easily to be integrated, right? Okay. I hope everyone understand why we need to change the variables. Okay. Now let's just take into our curve. Okay. So first is we can at least draw. Okay, draw. Our R is this one. Okay. We have the 1 0, 2 0, 0 negative 2, 0 negative 1. Okay. And what we have here, we have the line equations on the left side and on the right side. Okay. We can connect this line by the points, right? So we can think this as our change of variables, as we are already see from what we have suspected, right? In the beginning, we suspect that this is good choices, right? And then we take our new vertices, which is if we take the u is x plus y. Okay, so let me write here u is x plus y and v is x minus y. So we have let me change to same color. So 1 1, 2 2, and negative 2, and 2, right? And negative 1 and 1, right? Okay, and then it becomes our new vertex, and it's compared with this one. I think this is easily described in if we want to take the double integral, right? We can take this phi, okay, the phi as our outside integral, and we take this line here as our functions, right? So it's the inside integral, okay, if you know what I mean. And then to make our Jacobian formulations, or to make the Jacobian value, then we need to make the x as u v function. So we need to make out this u v and y equal u v. So we need to do some substitution or elimination to solve the linear equations, right? So x, or maybe start with u is x plus y and v is x minus y. So we can start with maybe adding these two. So then we can cancel the y. So 2x, let me write here, u plus v, or x is half u plus v. And similarly, we are going to write the y equation. So we subtract these two, so we can cancel the x. So we can write 2y as u minus v. So y is half u minus v. Okay, now what we are going next is we can check the Jacobian. If you forget what is inside of this Jacobian, this is supposed to be dou x, dou u, dou x, dou v, dou y, dou u, dou y, dou v. Okay, and this will get you to is half, all the positive will be just half, and then the last one is the negative, okay, for v. So we get this negative 1 over 4, negative 1 over 4 is negative 2 over 4, so it should be negative 1 over 2, but this should be in the absolute value later, right? Okay. Now if we look here, we are having the conditions that, as I said before, we are going to let the outside of integrals, okay, the order, the last one should be the phi, because it's a constant, and the inside integral will be the functions u as a functions of phi. Okay. Now we can write down, based on what we have, maybe write down if we have the r, okay, or maybe if we have directly asked, okay, for the interval, we can write this is u v 1 less v less 2, and for u is negative v less u less v, okay, based on what we have here, the just a line equation, linear equation of y equal mx, right? All right, and then we can write the conversion, the transformations. So from r, we could transform to s, and this will be e and then u over v. And then the dA, we need to involve the Jacobian, write Jacobian here. Let me write completely. And then, as I said before, we take du and then dv. So dv will be outside of integrals, okay, because it's a constant, okay. But sometimes you can also think which order you want to solve first. It depends on the case you have, okay. So write down the constant, and the u is from negative v until v. This is half, and the u dv. Maybe I will go to the right. Take half outside, and then integrate u over v. This will be 1 over v, or rather, because it's v, right? V u v, okay, and it's supposed to be from negative v to v, and then dv, okay. And then we take the negative v and v to the u, so we have be E minus 1 over E, right? And then the phi. And then this will be v squared over 2 from 1 to 2. This is 1 over 2. E minus 1 over E, or we have 3 over 4 E minus 1 over E. Okay, this is the answer. Okay, maybe before we move on, is there any questions? Sometimes in the change of variables, sometimes the one that you are looking for, how to transform the variables or the double integration. Sometimes the trick is to set up which one is u, which one is v. Okay, that's the trick. Like this equation here, it's I think it's easy to observe that we can easily take this into some variables u and this for variables v. Right? It's easy to see, but sometimes it's not really that easy for set up the change of variables. So you need to have maybe rewrite the form, see what it looks like, or maybe sometimes you need to change to, after you change to UV, you need to convert into a polar. So sometimes it can happen too. So you can have maybe multiple change of variables. So you can change variables and then change again to another variable. It can also be a possible way to see. Okay. Okay, any questions regarding the Jacobian? Maybe I will make it a little bit bigger. Okay. Any questions? No? Did we already mention about when we will have the finals? I think not yet, right? Okay, I think let me just explain until the triple integrals for the change of variable, and we can discuss about when we will have the final. Okay? I need your suggestions, also your decisions for the final. Okay, I think we are going to continue. The next section, it's the change of variable in triple integral. So it's supposed to be quite similar in the applications and in the process, but it has 3 variables. Okay. Okay. Next is change of variables in triple integrals. Okay. So first, the assumptions is the same as we did in the double integral. That is, the transformation should be a one to one. So T 1-to-1 transformations. One-to-one transformation that maps a region S in UV plane onto region R in XY plane. Not UV, sorry. It should be UVW. It should be UVW space. Now it's not a plane, it's a space because it's triple integral, right? and this is in XYZ space. So we need to make out equations for x is a function of three variables u, v, w, and then y is also a function of three variables, z also the same. Okay, and then the next part is the important thing in the triple integral is the Jacobian. Okay, what is the Jacobian? Jacobian for 3 by 3, or Jacobian of these transformations by 3 by 3 determinant. Okay. So Jacobian XYZ UVW, this is equal, okay, dou x dou u, dou x dou v, dou x dou w, dou y dou u, dou y dou v, dou y dou w, and then dou z dou u, dou z dou v, and dou z dou w, and that's Jacobian for the transformations by 3 by 3 determinant. So by this determinant, we can set up the transformations from this triple integral in region R. We can write in terms of region S, and then changing all with the transformations. So let's say x u v w, y u v w, z u v w, and then the Jacobian okay, and then du, dv, dw. Okay, so this is for triple integral. Okay. Okay, any questions? Well, let me give you an example on how this triple integral can be applied. And I think that way I just proving the formula for the spherical, and we can have exercise. And maybe before exercise, we can have some polling on the final exam. Okay. So probably we start with the example. Okay, the example for how we are using this at least 3 by 3 determinant, okay, for finding Jacobian value. Okay, now spherical coordinates. Remember that we have rho, theta, and phi. Okay, if we have the x, if we remember how to convert this, this is rho sine psi, cosine theta. Y is rho sine psi, sine theta, and z is rho cosine psi. Based on what we have here, we have conditions that have a possibility to make out our triple integral for changing its variables. Okay, so it's using the Jacobian for triple integral. Triple integral. So the Jacobian value and we are using rho, theta, and phi. Okay, so we make out our determinant. Okay, so the first line will be about x. Okay, so derive with respect to rho. This will be sine. Derive with respect to theta. This will be goes to okay, and derive with respect to phi. This will be cos. Okay, and then the second line, it's supposed to be y. So derive y with respect to rho, and respect to theta, and respect to phi. Okay, and the third line is z. Z is just rho cosine phi. So first it's just cos phi, and there's no theta, so 0. And this will be negative rho sine phi. So we could make the calculations through if we want, we could make another sine phi cos theta sine phi sine theta cos phi 0 rho sine phi cos theta. We could make this cross multiply calculations, but I would like just to use the normal way we are computing the determinant. So I will take this this line as our primary covectors. Okay? So this will be positive, negative, positive, negative, positive, negative, positive, negative, as in the matrix, if you remember. And then we take the cosine phi, and then we take this as our determinant, right? So we take that and write okay, and the middle one 0 is 0, so we don't count the 0, so we count the other one and this one, right? So it's negative rho sine phi cosine theta sine phi sine theta. Okay, and then we solve truly solve this slowly, takes time. So cross multiply. Okay, so cos phi is negative rho squared sine phi cos phi sine squared theta. Okay, and then minus rho squared sine phi cos phi cos squared theta. Okay, and this one, rho sine squared phi cos squared theta, and minus minus, so it's plus rho sine squared phi sine squared theta. Okay, now slowly but sure, we are going to have our sine squared theta and cos squared theta, so we can group this, and sine squared plus cos squared becomes 1. So this is supposed to be negative rho squared sine phi, or maybe just directly multiply with cos phi, so I will just write down as cos squared phi. Okay. And this one also the same, we will get negative rho squared sine phi, and then it's supposed to be having sine squared phi. Okay, and again we are having sine squared and cos squared, so we can group this together and becomes negative rho squared sine phi. Okay, so this is our Jacobian value, and it's perfectly similar to what we have in the previous spherical coordinates, right? We have this as our additional value to be added when we convert the rectangle or Cartesians to a spherical, right? Okay, and then we can write down our conversion to the triple integral r so we are changing all with the conversions. And then this is rho squared sine psi, dou rho, dou theta, dou phi. And it's supposed to be having the absolute value. This is due to the phi is from 0 to phi, and the sign of phi should be a positive. Okay. And this is what we have. Okay. The same equations for the conversions for Cartesians to the spherical coordinates. If you have any questions, you can let me know in the chat box. Okay, if there's no questions, I would like to discuss the schedule. Okay, I hope everyone can hear my voice and do some pollings. Okay, wait for a moment. I will stop the sharing screen for a while. Okay, let me do the pollings. And if you have others, you can mention later which date you prefer, and maybe that can be also our alternatives. Okay, I will open the poll. Please respond. Uh, Half of you not started yet. So better you check your phone or check your laptop. Okay, and please hear my voice. Check the polling. If you're unable to vote to cast a vote, uh, I I don't think you are able to decide later. Okay. We need to decide by today. Okay, still around 11 students not started. Okay, 9 and students not started. Okay, I think it's already more than half. We still have 9 students not yet started. So 9 students could, yeah, they could go to the Monday. So between Monday or Friday. Okay, eight students now started. Okay, and so far you guys choose the Friday class. Uh, 8 students not answering. Do you want me to count all these 8 students, or just leave them? So far, 4 students vote for Monday, 7 students vote for Friday, and 8 students not answering. So yeah, 8 students is quite a lot. Let me check. The total is 19, right? Total is 19. Yeah, probably you guys still taking a breakfast. Okay. Anyway, oh yeah. Wait for a few remaining minutes until the polls finish. Yeah, 7 students not responded. Not sure. Uh, if I know who that was, I can uh, ping and maybe sending you an email. But anyway, that's the online class. The teacher seems clueless about what you are doing right now. But that's okay. That's okay. Yeah. So far, Friday class, Friday class. Okay. Everyone agree? Friday class. Okay. Everyone, yes. Okay. Yeah. One student's in progress. You need to vote quickly. The time is 20 seconds left. But so far it's Friday, so well, this one student, whichever he or she put, uh, probably the still Friday. Okay. Okay, Friday is our final exam time. So yeah, in the morning, uh, do you guys have another exam in the Friday after our class? So suppose that we have 8 a.m. start. If we start 8 a.m. and we finish 2.5 hour, so it's supposed to be 10:30. So 10:30 supposed to be the final exam will be ending. Is there any course after my course in the Friday, June of 10? No, right? But I think uh, some of the students they have course after the Friday morning, right? Physics, right? Some of you are having physics or what course? I forget. Physics or yeah, in the morning. Oh, cam. But no course, right? For Friday 10, right? Yes, the finals is on June 8. So 10 supposed to be no no chemistry, right? For Friday. Okay. So I think Friday is good. I think good time morning. Okay, I hope you can wake up early, but and I think because it's an online exam, so you can do it at your room. Okay, so you don't need to hurry up and maybe prepare yourself, wash your face, and then coming to the school. So don't need for that, right? So you just prepare yourself, just wake up, maybe having a little bit of breakfast, and then prepare for the exam. Okay, I think that should be okay. So let me go back to our share screen, and let me remind you for the final exam. Okay, so finals, let me write here. Final exam, finals is 6 and Friday morning. Okay, I hope everyone okay if I just write 8 8 maybe just 8:30, okay? So that you can have more preparations, okay? Not too early. Okay? So this will be 2.5 hour, my predictions. So it's supposed to be until the 11th, right? 11. Okay. And how we are going to do our exam, I will tell you later, after some of the example that we will have. Okay, where's my okay, so 2.5 hour Friday morning. Okay, so please bookmark this schedule in your calendar. Okay, so you don't forget to join the final exam. Okay, let me continue a little bit on some practices or some examples. Okay. Okay, let me go through some example for this one. These questions. The question is just uh, sketch the image, I think. So a region R in xy plane is given. Find equations for transformations. Transformation T that maps region S, the rectangular one, in UV plane onto R. This is supposed to be a rectangular region, if the S, rectangular region onto R, where sides of S are parallel to U and V axis. So what we have in the question here is we need to find the transformation, okay, and then probably take some time to draw the transformations. We can check number 8. Okay, maybe we can check number 8 first. So we have the parallelogram with some vertices. So the idea, if you already draw the diagram for the vertices for this parallelogram, so the idea is to transform this into a rectangular shape that is easy to be calculate in if you try to integrate, for example. But this is just to find the t. Okay, the question is just to find the t. What's the possible t? There are some possibility, and we need just to find one way to make into our rectangular. So if you want to take into our sketching, okay, let me do number 8 for you. Okay. Take 0, 0 here, 0, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2. This will be negative 2 and 1, and then 4 and 3. This is 4, 3, and then 2, 4 here. So it's supposed to be, let me change the color into the dark blue. Okay, that will do. And then, oh, I forgot to write down. This is 2, 4. This is 0, 0. Now what we have here is we need to check every possibility for the line equation. So maybe this just taking ax plus by equals something. Let's say equals c, okay. And maybe taking these points, okay, and then we need to make out our line equations. I think you can try try one by one, take some time to check all the points, and eventually you will learn that this will be x plus 2y equal 10, and this is x plus 2y equals 0. I think you can start from the below here. I think it's because it's 0, 0, it's easy to be calculated. And here you get 4y minus 3x equals 0. And this will be 4y minus 3x equal 2, 4, 16. 16 minus 6 is 10, so it's supposed to be 9. Okay. Okay, now we have all this line equations, right? We have this line equation as our boundary. And then if we try to be observant and looking at what we have here, I think it's best if we take this 4y minus 3x as one variable and take this x plus 2y as one variable, because they have a boundary that is clear, okay, from 0 to 10, right? And both of them are from 0 to 10. So we can set u is 4y minus 3x, and maybe 3 is x plus 2y. And by setting this, we define the transformation of T inverse, right? That maps the R to S, right? Okay. So in S, so this is R. So in S, what we have is we will have a square that has 10 unit sides. So this is x, y, x, y. This is u and v. U, v. So this is 10. This is 10. This is s. Okay. This is t. Okay. And now we need to set up t, which means we need to make out our equations. So x equal a function of two variables u, v. Okay, so we take x as u, v, and y also u, v. So take the 4y minus 3x. V is x plus 2y. Okay, take 3, and then we plus this 2. So u plus 3v is canceling this x. So 4 plus 6 is 10y. So y is 1 over 10 u plus 3v. And then take the other cases for x. So we are going to multiply 2. So this will be u minus v, and then equal minus 4x, right? Oh, 5 should be 5. Should be 5. So negative 3, negative 2 is negative 5. So this will be x equal 1 over 5 v minus u. Okay. And this will be our transformations. Okay, so transformation. So one possible transformation is given by x and y. Okay. Well, you could have another way if you want, like maybe taking the change, switch this u and v. Well, it doesn't matter. It doesn't really matter. And when you have a calculation in the integral, it's also resulting the same result. It will be the same result. Okay. The next challenge is number 10. I think number 10 is that good good questions. Okay, because it's not a typical just a line equation. It has a curve. It's a hyperbola. So you have a hyperbola y equal 1 over x, y equal 4 over x, and lines y equal x and y equal 4x. And by this, all these sides, all these curves, you need to convert them into a rectangular shape or a square shape. Okay, a square shape like this one. Okay, maybe wait for a while for you to take some notes from here. Okay, the question is not asking integrations or anything, so using some calculations, but this is just asking how do we observe or how do we take some distinction from the case to transform some shape in some into another shape. Okay, let me continue. Okay, so I think number 10. Okay, I would like to try that. Okay, so first of all, you could write the all the curves that we need to at least to see the drawing. If you want, or if you don't want to draw, you can directly see from the equations. I think it's also possible and still okay. Okay, what you're noticing here is they have 4, right? 4, 4. So suppose that we can make some simplifications to make out some sort of a setup for a transformation. Okay, but let's just say that we are going to just draw first. Okay? We see what it looks like. Okay, first is maybe the line first. Okay, so this will be y equal x. And then we have 4x, 4x probably around here. So this is 2, 4 maybe here. Yeah, maybe here. This is okay, let me write in terms of y over x. Okay. This is y over y over x equals 4. Okay, and then we have, let me change the color with the green. Maybe around here. That is the y equal 1 over x. And then that way is dy equal 4 over x. I think should be a little bit having more in line like that. Okay. So this is your R. Okay. Check all the intersections. Y over x equal 4 and y equal 4 over x. Or xy is equal 4. So 4x squared. Okay, so supposed to be 1, right? Supposed to be 1. So this is 1. Supposed to be the same intersection here. This is 1. And this is y over x equal 4 is y equal 1 over x. So y squared is 4, so it's supposed y is 2. Y is 2, then x is half, right? And then this one, y over x equal 1 and y equal 4 over x. So 4 over x squared equal 1, so x squared equal 4, so it should be 2. I think we get all system here. So when x equal 2, y also should be equal to, or it should be equal. Yeah, my drawing is a bit wrong. Okay. Okay, anyway. Okay, now let me erase all my calculation here. A little bit messy. Okay, now looking at these equations, okay, after we have some drawings. By looking at these equations, okay, if we look on, if we set up all the things, okay, if we set, since they have 1, 1, right, 4, 4, okay. So if we take this x, y, and y over x as u and v, I think that is one way to make our change of variables, and I think it's really showing that we can transform into our rectangular shape, right? Okay. So if we take this u as xy or v as y over x, or you can take it switching the order, that doesn't matter at all. We can define a transformation, or rather the inverse transformation form that maps the R into new S image. Okay. that is started from u equal 1 to u equal 4 and v equal 1 to v equal 4. Okay. And if we solve this, solving the u, x, y, and v, y over x in terms of x and y, this will give us, let's say we take substitutions here, that y is xv. Okay. So u will be x squared v. So x, okay, so x squared is u over v, or x is square root of u over v. And same way, we take the x, let's say x is u over y, okay? And then we are going to have y squared equal uv, right? And then y will be square root of uv. So through transformations by x equal square root of u over v and y equal square root uv, we can transform and maps R to S. Okay. Okay, I think we can move to some other example, some other practice. See the change of variables, and mostly the changes of variables will be will have much variations in the structure in the question types when you deal with the double integral. When it is just having triple integrals, sometimes it takes time and really complicated. I think there are only a few questions regarding to the triple integral, but we can still have triple integrals for the change of variables. Okay, I think we can move on to the next question. Let me check whether I have unwrapped the other questions. Okay. Now we need to compute the double integral with some region R as follows, and we have given suggestions for the transformation. Okay. Maybe we start with number 19 because it's an ellipse, so it's not our usual questions that we have. Usually we have the parallelogram, okay, we have the line equations, okay, we have some structure on the sides, but we don't have the ellipse. Okay. Okay, first, if we are given the transformations, okay, we already have this function equation to connect x with u and v, okay, to x, y to u and v, then we can start with the Jacobian. Okay, we start with Jacobians for 19. So Jacobian since it's just 2u and 3v for each x and y, so we will have just 2, 0, 0, 3, so it will be 6. Okay. All right, and then we have the ellipse. Okay. Okay. And if we exchange x and u, okay, so x, u, x, y, convert to u and v. Okay. So 9 2u squared plus 4 3b squared. I think it's nicely become all 36, right? 36u squared plus 36v squared equal 36. Or we could say that this is u squared plus v squared equal 1. Okay. So the ellipse, okay, when we have the ellipse, when we transform, it will have the image of the disk u squared plus v squared equal 1. Or the area will be from 0 to 1, less equal 1 for the area itself. Now, if we have the double integral r, and then what is this? X squared dA. Then we could take, okay, double integral. Then r is our u squared plus v squared less equal 1. Okay, and then x squared becomes changing with u becomes 4u squared. And then we take the Jacobian 6 as we already calculated the Jacobian. And then du dv or dv du, we can just write like that. Okay. And if we see the structure of this double integral, we could take another transformation, right? Because we know that from here, this is a circle, right? It's a circle. So its double integral is it's a circular equation. Then we could convert to polar. So we just convert to polar as usual. Okay. So we convert to polar, and we know that this is having the radius is from 0 to 1, and it's a full circle. So the theta is just 0 to 2 pi. So we could just take the double integral, write 0 to pi, and then 0 and 1 for the r. And then this will be 24. U squared becomes r. So we can write u is r cos theta and v is r sin theta. Okay. And this will be r squared cos squared theta. And this is r dr with theta. And we can solve this and take times to solve. And we can separate for each variable, so r cubed dr. And this will be 12, because I will take this into 1 plus cos 2 theta. Take the double angle, and this will come this. And this will becomes theta minus, right? or plus, okay, because it's integral. 0 to 2 pi, and we have 1 over 4. So 2 pi multiplied by 12 is 24. Divided by 4 is 6 pi. And the other part is sine 2 pi 0. So we have 6 pi as our answer. Okay. So you can freely transform any variables you want, actually. It doesn't restrict to some sort of method. Okay, you can open your mind, broaden your perspective. We can actually transform with any possibility that we have, like from the previous example. It shows you that you can actually choose which way you are going to take the transformations. And of course, the objectives or the goals for the transformations is to simplify your calculations. Okay? So when you transform the functions or transform and takes the Jacobian value, and when you try to compute the result, the end result, when you feel that it's making things difficult, then you're taking maybe the wrong transformation. You need to check other way. You check other possibilities and make your computations easier. Okay. Okay. I think if you want, you can try later for all the questions here. I will just going through another example. Okay, you can. Y is your cos theta. You mean here? Yeah, I convert to polar. Okay, here's the deal. Okay, the region. Okay, if you read out the questions slowly. Okay, the region is bounded by the ellipse. It's bounded by the ellipse. Okay, so R is an ellipse. Okay, and you have this transformation x, y to uv. Okay, if you check this to our ellipse, it gives the circle equations u squared plus v squared less than 1. Okay, all right. Okay, got it. And now we are going to integrate this. Double integral is r, right, and integrate with this x squared at dA. Okay, and then we change the with the transformation uv. Okay, change xy to uv. Then we have this x squared becomes 4u squared. Put the Jacobian value and write du dv or dv du. It's up to you, right? Now next, since our double integral is described by a circle, how do we integrate easily if not with polar? Well, you could still do the you could still do this, right? And you can take the, let's say we have the plus 1 minus x squared or minus 1 minus x squared and put in the double integral. Well, you can still do this. But of course, this is complicated, right? Difficult to write. So that's why from this side, change to polar. Okay, change to polar. So the polar u is r cos theta, right? It's the same like when we did with x. X is r cos theta. Okay, right? So it's change of variables and then change again one more time. Okay. Okay. Do you get the idea, Evando? Is it clear? Okay. So I think one way to think of this polar conversions, okay, whenever you have a curve that is, so you change the variable and you found out that it has a circular, some elliptical shape, and you can easily transform those shape into a polar, then you can just do the polar. You can just do the polar after some sort of finding Jacobian, blah blah blah, and you can see that, oh, it's another circle, then go to the polar. Okay. A similar things when you have the triple integrals, right? When you have some sort of, oh, you need to transform into spherical, then transform to spherical. But I think there's only a few questions like that. Mostly the question will be this double integral, and after Jacobian, you need also using a polar conversion, okay, and taking to polar coordinates. Okay, I think we can move to, I think, one or two example, and then I will explain what will be in on the finals and what should you prepare. Okay, what should you prepare? Yeah, aside from some exercise. Okay, let's move to next page. Okay, let's see if this is the questions. Oh yeah. So the question is evaluate the integral. Okay, evaluate the integral, and it doesn't give you the clue for the transformation, and I think you need to be aware of that, and you need to find out which transformations is best to transform the xy into uv, okay, into uv plane. And sometimes you can draw if you want, but I think drawing sometimes takes time and maybe wasting your efforts. Okay. Firstly, maybe observe the equations. Firstly, observe the equation. So you have the cosine here. So there's two questions, so the first and the second. So you have a cosine. Okay, let me write in the next in the bottom here. So cosine y minus x, y plus x. Okay. So if you want to integrate this, okay, let me just integrate with a single variable. Either dy or dx. This integration seems difficult to convey, right? If it is just a derivative, I think it should be not too a little bit complicated, but still doable for derivative. Right? But for integral, or integration, this seems really tough job, right? Unless you just use your calculators, and if you would like to put some values, right? But it doesn't really give you much choices, okay, for how to integrate, unless you are going to change the variables. Okay, so one way to change the variables, okay, if you look on the structure of the equations, it's clearly having the y minus x and y plus x. Okay, so if you have this, then it's certainly giving you a vibes that maybe we need to just using the y minus x and y plus x as a one variable. So if we let this becomes u and this becomes v, maybe it will help us to solve. So let use this. Let this y minus x become u and y plus x become v, and we need to take these two equations into x as a function of uv and y as a function of uv to make our transformation, right? So we could take this, maybe plus first, so 2y equal u plus v, or y is half u plus v. Okay, and then take minus. So we could have minus 2x u minus v, or x is half v minus u. All right. Okay, next we could write the Jacobian first. Okay, before we are looking at the interval, we can take the Jacobian first. The Jacobian from these two equations. So dou x dou u is half, dou x dou phi is also half. This is negative half and half. Oh, I wrote this is x. I make a mistake. Should be minus here. So this is x. This is y. Okay. So we have negative 1 over 4. Negative 1 over 4 is half. So it's negative 1 over 2. And then we have the vertices. Okay. The vertices on the xy is 1, 0, 2, 0, 0, 2, 0, 1. So we can convert into uv using our conversions. So y minus x for u. So this will be minus 1. And y plus x is 1. Okay. And then y minus x for u is, this will be negative 2. And then 2. And this will be 2, 2, and this will be 1, 1. Okay. Now you are going to see that u is going to be from negative 1 to 2, and v is going to be from 1 to 2, right? But we are going to look the vertices, and I think it's not a rectangular shape, so I believe we take the deeper looks on how it looks like from. So we need to help some drawings. So negative 1, negative 2, 1, 2, 1, 2. Okay, negative 1, 1 is here. Sorry, here. Negative 2, 2 here. Oh, it's a trapezoid, right? So 1, 1, 1 here, and 2, 2 here. So it has a trapezoidal. I think it's okay just using v for outside integral as mentioned before, right? So this will be 2, and v equal 1, v equal 2. And then the rest will be, this is, I believe since it's 1, 1, and 2, 2, this will be u equal v, and this will be u equal negative v, right? So this line here, and this line here. So we can simply say that v is from 1 to 2, and the u is from negative v to v. Okay. So we need to set up as a du dv. Okay, du dv. So writing the equations is cosine. Let me write the question, cosine y minus x, y plus x, right? And then what else? Oh yeah, just dA. And then this will be equal to cosine u over v and du dv. This is 1, 2, negative v and v. Okay. Oh, the Jacobian. I forgot the Jacobian. So half here. Okay, so take half outside. And then write down the integration of for p. So cos uv du, it's integrate cos u. It's supposed to be sine u positive, right? Sine u over phi, and then we multiply with phi because of integrations, right? If it is a phi u, then it's supposed to be over phi, but it's over phi. Yeah, I hope you understand this. And plug in the negative phi and phi, d phi. So we will have phi sine 1 minus sine -1, right? So it's become negative sine 1, so it's plus. Okay, so plus 2 sine 1. So we have 1 2 phi 2 sine 1 d phi, and this will be phi squared over 2. It's sine 1. Okay, and this will be 4 minus 1 is 3 over 2. So 3 over 2 sine 1. Okay, so the crucial part is, I believe the crucial part is taking this, okay, making this into this. Okay, this is the crucial part. The rest of it, I think still easy to be approachable. Okay? Letting this u and v as these transformations, taking the Jacobian, still not really that difficult. But I think set up the integrations for the double integral, the interval is, I think you need to be careful on this, okay, on this part. Okay, that's the one example. Another example, if you look on the second questions here, it has the bounded by ellipse. So you need to be aware that when you have the ellipse, probably the image that you may have will be a circular or having a conversions into polar. Okay? Later on, you can convert to polar. Probably it's that way. So first is we need to imagine what will be for x and y to change into our conversions. Okay, because it's giving you the same ellipse, like having the same constant 9 and 4. So you could just have some imaginations that how which x and y, when you convert to u phi, it will resulting having a common numbers for 9 and 4, which is at 36, right? 36 that you can imagine. So you can have x equal 2u and y is equal 3 phi, like the previous one. So we take x equal 2u, y equal 3b, so that when you multiply, it will result on that 36. Okay? So it's become not 2y. So sorry, it should be u equal to x. U equal to x, so that you can define later. So u is equal to x, and v equal 3y. Okay. So when you exchange this, you will have this will be result in, oh no, it's supposed to be 3x and 2y. Sorry, so you can cancel each other. So when you have this, then you can have u squared plus v squared equal 1. So you have this a circle, and another implication from the question is it's on the first quadrant. The first quadrant. Okay. The first quadrant means it's only 1/4 part of the circle. So if you have a circle, it's only this part. Okay, the first quadrant, which means your theta is from 0 to pi/2. So later on, you can convert to polar, taking theta from 0 to pi/2 and r from 0 to 1. Okay, I think you can finish off what I have given for this part, and you could have some calculations. Okay. I think it's not too difficult to check, right? And since this sign, the equation will be sine and then change into u squared plus v squared, and then it change into polar. Polar will be r squared, like that, and it's easy to be integrated by sine r squared. Okay. You can take sometimes to use substitution method, okay, because you have r, dr, d theta, and use substitutions, r squared, okay, du, 2r, dr, and you can continue this part, okay. All right, I think we'll just, for the contents for today's lecture, I will just end until here. What I would like to continue is I will explain the final exam, what you need to prepare, and also what kind of platform we are going to use. Okay. Okay. Before that, maybe if there are any questions. Okay, is there any questions? Is there any questions regarding to this double integral in the change of variable? And the change of variable, I think you can use this in many ways. Okay, so if you jump to another course, okay, you learn another course, and in that course you need some calculus method to solve, like integral or derivative, and maybe you need to simplify by changing the variables. You can still using these multiple variables, because it's you can actually use this in any calculus type questions. Okay, when you want to simplify some equations so that it can be easily to be integrated, then you can use the change of variable. Okay. Okay. Any questions? Okay. Okay. If there's no questions, then let me repeat that the finals. Let me explain when is the final. So finals will be Friday, okay, 10th of June, sorry, 10th of June from 8:30, okay, until 11. Yeah, I hope everyone has the time, okay, for until 11, okay. At least this will be 2.5 hour, 2 hour 30 minutes, right? So what will be for the final? First is the topics from chapter 12 to chapter 15. But mostly chapter 14 and 15. 12 and 13 will be a minor. But there will be a 12 and 13. Okay? And then there will be 2 sessions. Okay, so the first session, it will be around 20 to 25 minutes. We are using the quizzes. And I will be the one that will guide the questions. Okay, so this will be like a game, sort of game for 20-25 minutes. Okay, we will have a quizzes. Around 10, 12, 15 maximum questions, short questions. Average time is 2 to 5 minutes. Some of it maybe 1 minute just to read the statement. Okay, this is the first session. The second session, this will be the rest of the around 2 hours. Okay, so around 2 hours, we are working on the platform is called the Flexi Quiz. You don't need to download anything. Just click the link. I will give you the link later when we have the finals. So we are doing the finals, okay, together in the WebEx. Okay, so you click my WebEx link. We are going to do the quizzes. I will make some instruction for you, and in the second session, I will give you the link through the WebEx. Okay. Now the link for the finals with the Flexi Quiz, it's a platform for similar with the quizzes, but it's more having more optional for mathematics equations and how to sort of writing all the equations easily, okay, rather than the quizzes. So in the Flexi Quiz, first is my suggestions. Okay, use a laptop for stability. Okay, and then your browser, if you're using Windows, please use private browser or incognito mode. If you don't know, please Googling it how to open private browser in your browser. Okay, if you use Chrome, it's called the incognito. Okay, because it has some troubles when you are having a lot of case files. Okay, or if you want to clean case files, it's very easy. You can clean and then just do as a normal browser. It's still okay. But if you have difficulty finding out what is that, just using private browser, it will be very very safe. Okay, for the link. Okay? I think if you are Mac user, I think I haven't found any trouble yet. But if you are using Windows, I think you need to use a private browser. And third, please read all the instructions very clear. Before you enter the link, after you click the link, you will have some sort of welcoming message. Please read all the message, okay? Because there is some instruction how you are going to write some equation or maybe some sort of numbers, okay, numberings, okay. Oh, by the way, this Flexi Quiz I will also use in our quiz. Okay, in our quiz. So we will. I forgot to mention, we still have one quiz. So quiz 4 for chapter 14. Okay, it's supposed to be this weekend. It's supposed to be this weekend. I forgot to mention. So quiz 4, I will use Flexi Quiz. Also, this just to try your computer, your browser, your stability. Okay, this is I'm just giving you the link. You can work the quiz whenever you have the time. Okay, I will give spare time for 3 to 4 days until Wednesday. Okay. Okay, and then read the instruction. Okay, read the instruction carefully. There will be 3 parts in these sessions. So part A, B, and C. Okay. Part A and B, you just need to fill in the form, and I will make a scoring based on that form. Okay. And for part C, aside from fill in the form, so fill in the form and write steps in a paper, and then after you finish, scan and send to my email. read the instructions carefully. You will know my email from those instructions. Okay. So after you send all the part C in the paper, scan and send to my email, then finish. Okay. You can finish early if you want. Okay. But remember, for this part A, B, and C, it will be this divided in each page. Okay. So page one is part A, page 2 is B, page 3 is C. Okay. If you jump from page A to page B, make sure you already complete all the questions in part A, because you are forbidden to go back. You cannot go back to part A, to the first page. So it's not allowed. So within this 2 hours, please manage your time wisely. Yeah, 2 hours or maybe 55 minutes. Okay, around 50 minutes. Okay, you need to manage your time wisely. I will give you time around, because we are ended on 11. Maybe I will just give you plus 5 or 7 minutes, 5 to 7 minutes to send the paper through email, via email. Okay. So that is generally what we are going to do. Okay. So if you feel you lost something here, we can still have another discussion next Monday. Okay. But next Monday, I will just have some review on our courses and prepare for a final exam. If you want, you can skip my class next Monday. Okay. If you have another schedule for final exam preparation for other course, that's okay. If you want to skip my class next Monday, it's okay. I will not count the attendance on next Monday. Okay. So suppose this is going to be our last class. Okay. You can choose. Okay. You can choose to come next Monday or not. That's fine. So that's what we have for our finals. You can open your notes. Okay. But please be careful. Okay. When you open the Flexi quiz link, I will set. You can just click one time. So if you are maybe you opening another browser, you look for something in your computer, maybe it will have some trouble with your Flexi quiz link, and maybe you accidentally close, then you cannot go back in. Okay? Unless you have some sort of technical difficulties, you can discuss with me. Okay, for the Flexi quiz link. But be careful. Okay, be careful. You can prepare your notes, everything, calculators. Okay, but please work alone. Okay, don't work together. Okay, if you are in one room with other students who have the same exam as you, then please work alone. Okay. If I know that you are having a group together, or maybe having a chat discussion through Line or etc., and you share some other answers, and I know, and you'll be directly get a 0 in finals. Okay. Okay. I hope that is clear. So I give you freedom to use any notes you have. Okay. So I hope that's enough, sufficient, and you can manage your time wisely. All right. So I think that's it in the finals preparation. And suppose this is your last lecture with me, I would like to say I really appreciate all the students who comes, okay, and join the class, even though it's an early morning. I know that some of you are feels lazy in the morning, right? But I do appreciate, especially when we have the offline class, you come to the class in the early morning. We have some session in the morning. And even though now it's online, it's easier for you just to wake up and then go to the class. So, oh yeah, QR code. So I would like to thank all of you, and hopefully you can pass my course. Okay, you can pass my course. I know some of you feel my course is a little bit, not a little bit, maybe difficult to pass because of the questions and etc. But I hope you can pass the course. Okay, and yeah, see you again if you want to take my other courses in the next year. I will teach several courses in this. I think, yeah, in the second year and the third year, I will teach some courses. Okay, so let's just say farewell. If you want to skip my class next Monday, that's okay. So yeah, I think that will be the end of our lecture. Again, thank you all and see you. Yeah, you're welcome. You're welcome.